Yeah, you're live.
Hello. So we have to review the graphs generated by Red, right?
Graphs.
I'd rather review some KiCad PCB designs.
Oh yeah. So basically, I did the design on. Let me share. Hmm. Not this one. Hmm. Yeah. So this is the schematic I made. So these are the basically the voltage translators, and I put in two Arduino Nanos on both sides because they give the footprint. How many of you know basics of PCB design? Okay.
I've been struggling to learn it, so I would appreciate any basic information you can provide.
Yep. Plus
Okay.
one, only 5.
I went through and designed a whole thing in Flex AI, and then the whole thing glitched out, and all the lines went like haywire. I was like, maybe a web browser based PCB designer isn't going to work.
Yeah, I started with Flux, and then I was getting really confused. So I just used a desktop app, and then I was a little familiar with KiCad, and yeah, so I've used I had done it 10 years ago, and it was a little hard to use at that time. But this time, a lot of the tools have become much better, and it's really a good tool now because it's like you small and medium sizes enterprises just use it, and you can do really professional designs with KiCad. But it used to crash sometimes, but yeah, for me that doesn't matter. But
Is it
maybe for
paid or is there a free
it's
community
free.
tier? Oh, okay, perfect.
It's a
So
open source,
open source.
free tool, and it's widely used. So there are two parts when you do a PCB design. One is the schematic, and one is the actual layout of the physical board. So the schematic is basically a symbolic representation of what you do or what is there on the circuit. So you have components, and then you have the connections between them. And then on the layout, you have basically the actual dimensions of how the routing happens on the physical board. So this is what I made. So each of these tools are separate tools, I think, in KiCad, and then you can click and open them. And yeah, so I learned a lot of things while doing the manufacturing too. So what happened was I first designed the schematic. This went well, and then I went to this. I laid out the components, and I routed the parts, and then I went for manufacture, and I found that some of the components are not available on JLPCB. Well, first I tried a manufacturer in Germany called Eisler, and it gave me a quote of $250 for 5 votes. And for me, that seems like not reasonable for putting it on tumblers. Then I started searching this. There are two companies in China which are basically providing this PCB manufacturing services, JLPCB and PCB. And yeah, I just started with JLPCB, and then I manufactured with it. So JLPCB also has its own sourcing inventory. So the first thing generally what we need to do is like whatever components we are going to use on this schematic, we need to check on JLPCB website if they have it in their inventory. We can source them. So they have like a global sourcing section, and then they have their own inventory. And if they have the component in their own inventory, you can manufacture it faster. And I think there is some extra charge for sourcing it from other sources. So I'll show you how it looks, the interface.
And then you could presumably just get the PCB and add components yourself.
Yes, but then I didn't want to solder like surface mount components.
Right.
And if the components are really small, it's a problem. And then I didn't have this, what to say, the surface mounting soldering iron or the hot air iron, which you can blow air through hot air through it, and then it surface mounts. You can solder surface mount components. So I could have done that, but then I wanted to try out this manufacturing part itself, so that it's like I wanted to learn how to manufacture PCBs remotely. So let's see.
I think Hitesh, you're muted if you were.
Sorry. Yeah, saying it's hard to see. Can you zoom and tell us what these 6
Yeah.
chips are?
Just a second. Yeah. So the first thing you have to do is, after you sign in into JLPCB website, you have to go to their JLPCB like parts. So this is their sourcing place. So you can find the parts you want in here, and then you select them, and then they have their own part number for it. So because that is required when you are giving the file for manufacture. So it requires 2-3 files specifically for manufacturing the BOM Excel and the positioning of the parts in the BOM. So these 2 files need to be there when you are giving it for manufacture. So yeah. So this is the Texas Instruments level translator. And then let's see. You right click on it, and then properties. Somehow, so KiCad itself has a lot of components inside. You can just drag and drop components here. So this button here on the right. So this is the components inside a KiCad, and you can just search voltage translators. So you will get all these different voltage translators. I selected this one because I had used that while using the testing, like the breadboard for prototyping. I had used this, so I just selected this one. And then you just click OK, and then you can drop one inside. And yeah, this is just the Arduino Nano. So well, because the pinout for the ESP32 is the same, so I just dropped in here because when you go for the PCB layout, this will have the same footprint. So footprint is basically the actual area which it will take on the PCB board. If you go,
So even though you're not putting an actual nano on the board, you want to put like headers, but you can wire up the
yes,
schematic so that
yes.
I see.
So basically this
It placed the holes for you.
yeah. So if you put anything with the footprint of nano, it will create the same. So you can also create this footprint. So if you go to this footprint editor, So if you, let's say, if you don't have any component inside, so you can also create your own footprint. So I had tried a few components, and then where is it? Then you can create your own library of footprints. And
So that's for if you can't, they don't have the
Yeah.
thing that you want.
Yeah. So I created some libraries. So either you can create the footprint, or if you don't have the footprint, you can go to there are like a couple of websites from which you can download the footprint. So I was using this website called Snap EDA. So this will have footprints of many of the components you are looking for. You can just search for, let's say, Texas. What was that component? Let's say Arduino.
Why do you need like a particular part? Like, aren't they all dip packages with standard spacing? So shouldn't it be enough to just specify the number of pins on each side and you're done? Or
Mm, no, you won't get the part, right? Because like although each component has a different number of pins, right? Arduino has maybe 25 pins or 12 pins on each side. So you could either place one single, but then need to know the distance between the two rails.
I thought that was
Example.
standard. That's all. Oh, okay.
So you can. This is standard. One side is standard.
Oh, so the
So I
width
think
may not be standard. Okay.
yeah. So I think this is like 2.5 or one. I don't know the stand, like what is the
I
actual
think it's
distance, but
1/10 of an inch. It's 2.54,
yeah,
right? So it's 1/10 of an. Okay, so
yeah.
you get the footprint from the chip you're adding, and these are through holes, but the board overall is surface mount. So only the parts that you're going to add later will be through hole.
Yes.
A-
So I
And
could have done all of them as no. I don't think these are available as these. Maybe they are available, but I just took the surface mount because I wanted to see how it's done. Because JLPCB, when you give it to manufacturer, they only do like SMT placement on one side. So they don't do SMT placement on both the sides. I don't know the reason. Maybe like it's maybe cheaper that way. But yeah, it's a really cheap service. Like the boards were like 3 euros or something, 3 or 4 euros, five for 5 boards, and then manufacturer is like maybe 20. So overall, it was 24 euros with sourcing of the components. I think manufacturer was like 10 or 15, and the rest was the actual component price. If you don't manufacture it, you could get it within less than 15 euros. Uh, uh, or no, it was just 3 or 4 euros for the PCBs, and then the German one was what 13 or 14 euros for the PCBs without the assembly. So yeah, it's almost 10 times cheaper in China.
It's wild. How do you think
So,
assembly
yeah.
works? Is it automated?
Yeah, it's
People
automated.
soldering?
Yeah,
How does this work?
no. It's an automated machine. You have not seen a PCB assembling machine.
we
Okay.
haven't. We should
I did
look up
watch a video on like Raspberry Pi assembly or something.
No, it's really like highly automated stuff.
Yeah.
So I used to work in an electronics manufacturing company before, and they used to have these machines. So PCB manufacturing.
Routing is often considered the most tedious part of.
Yeah, I think this one.
PCB 101 Academy.
Reason for many tests and
That might be
inspection
helpful.
after this stage. With Valor Material Management, we can conduct stencil verification. Typical to many manufacturers, it allows for high accuracy and flexibility. Valor process preparation can help in generate. We'll collect data from the different testers, including the pins, contact the pads will be examined. At this point, the SMT process is complete. Following the SMT process, we have additional placement technologies such as through-hole and manual.
Yeah, I think this is one of the companies. So PCBWay is one of the companies that you could use to manufacture. Well, so the components are actually in a what do you say, in a reel, and then you place it all the reels and the components here, which you want to put on the actual PCB, and then the machine will pick it up from that roll and then place it here. And then actually in the previous stage there is some solder paste pasted on the pins or the pads so of the components, and then the PCB will roll over here, and then the pick and place needle will I think there is some vacuum based needle which picks up the components from the reel, and then it will place it on the PCB, and after that it will roll to the oven, and then the oven will heat, and then the solder place will melt, and then it will cool, and it will so components are stuck. And then you have to be really careful about how the components are how the reel is placed, because the components also have a orientation, and and sometimes what happens is, like, for small components the orientation might change and you might not know. So like I have debugged problems in which the components were shifted 90 degrees, and everything would be correct, like the hardware would be correct, the software would be correct, and you wouldn't know why the problem is happening. And then how would you know that it's a problem in the manufacturing, right? So it's really hard problem to debug for really small components, because once the component is rotated and mistaken, so you have to specify what is the orientation of the component, because after the manufacture is done, it's really hard to debug which component is and most of the people would not think that the orientation in the manufacturing process is wrong. So this is like one of the hard problems to debug when you are manufacturing PCBs.
Dysonin varsiimuri, nyt varsin hyvään hintaan. Gigantista.
Yeah, so when you give it for manufacture, it goes through a DFM department. So I think both these companies have some DFM, and they check your designs for manufacturing. And if there are any defects, they will ask you to correct it. So the Gerber file is one of the outputs from the KiCad, which you will need to upload in the later stage when you are done.
Dysonin varsiimuri nyt varsin hyvään hintaan. Gigantista. Dysonin varsiimuri nyt.
We have to watch a lot of ads too. But yeah, basically, if you don't have the footprint, then you could go to this website called SnapED or SnapMagic and then search for the footprint and you'll get it. So I don't think they have the ESP32 Nano, but yeah, but KiCad already had this. And then you go here and then you can download the footprint and then import it to KiCad. And then that way, so some of the components I didn't have the footprint. For example, this one. This buck converter from 12 volts to 5 volts, the footprint was not there in KiCad, so I had to import it here. So the first thing you need to do is like basically, sorry.
Yeah, quick question. The board is two-sided, right? It looks like you're mounting the nanos on the opposite side from the other components because they looked like they were overlapping. Or was I misreading?
Yeah, it's a two-layer board.
Okay, so you kind of have to do the mirror. Yeah, that's the diagram I was looking at. So, does the software automatically take care of? So, when you have the conceptual schematic and it's translated to the physical floor plan, does it take into account things like mirror symmetry if it's on the reverse side, stuff like that?
So the schematic editor doesn't have any concept of two sides or something. It just has the components and you lay it out there. And but here you have to select when you start the board. You have to select like how many layers you want.
Okay.
And then like you can have up to like 10, I think even 50 layers. But I'm not competent enough to design more than 4. And yeah, I've never done like manufacture of or at least design of 4. I've only done 2-layer, but I think for protos, 2 layers are enough. So this could be, I think, like the size could be reduced even further, by having 4 layers, and it's by having even smaller these routes. Yeah, I think I did it with half a millimeter of the thickness of the routes, but you could have it smaller. But and then yeah, it allows you to make smaller boards when you are having more layers. I did it with 2. It was just easier. So once you have like found out from JLPCB like which components you have there, you just select those components and then check the footprint. If then you need to check if KiCad has this components. If KiCad doesn't have this component, then either you can make your component in here like something called symbol editor, or you can go to SnapEDA and then download like the symbol with the footprint. So if you go to SnapEDA, it also has the symbol here, so you can download both of them and then import both of them in KiCad, and then you'll get the symbol and the footprint. And yeah, and then after you have placed got all the components, you need to go to the data sheet of these components and check out how they are like electronically working, so that you can put the actual components. So let's say okay, this doesn't have, so you can also link the data sheet of the component here. So if I put in the URL here, then you can just go in and click here and it will take you to the data sheet of that component. For example, this one, this was already there. So if I click here, it will take you to the actual data sheet.
And is this connected to a simulator in some way?
Yeah, there is a simulator, but I haven't used it. So there is a SPICE-based simulator. SPICE is a common electronic simulator. I think it's open source. So I think it can run simulations on this, but I haven't tried it. Where is it? Yeah, simulator. Show simulation window running Spice. Yeah,
By
I didn't.
simulation, Meyer, you mean for validating the board or something like that in software before
Yeah,
Meetup?
we have a design, and now I can see the signals.
Yeah.
Timing. Make sure that I don't have any shorts. That the voltages match. What they're supposed to match.
Okay.
There's different levels of simulation, but
Well, in large boards, you generally do some simulation because there are so many components. It's hard to keep track of what is happening. So generally, you use the Spice simulator, and then I think there is a simulation model you need to import of each and every component, and you will basically be able to click and see if the voltage is coming on that section of the board is correct or not. For large boards, you will do that. But yeah, I didn't do any simulation, so I'm just hoping there are no bugs.
But there is no basic. The tool doesn't maybe guarantee some basic checks, the validation. That is, for example, voltage
No,
not connected
schematic is
or
just a symbolic representation. You need to
okay.
simulate here. So with Spice.
So someone like me would just be doing whatever, it would not work, but there would be no feedback.
So yeah, so I think I will have to import the simulation model. I will have to check, but I didn't bother to check. It was just
Okay.
such a simple circuit, and just I winged it.
But it's possible
So
in KiCad. There would be some
yes,
option
yes,
somewhere, no? Okay,
yeah.
okay. Thank you.
What is this component? AP7380. So this is the component I chose. It's voltage converter from Diodes Incorporated. It converts just 12 volts to 5 volts. And then, yeah, so this is the basic circuit you need to have. So I just use this circuit, and I placed two capacitors and that connected it in the same format as the data sheet.
And you said
So
you
yeah,
did a breadboard test before making this design.
yeah, yes. Yeah, so I could have placed some more capacitors here, but yeah, I didn't place it. So after the schematic, after you are connected, so in this Texas Instruments level translator, there are two sides, and VCC-A, if you connect it to 1 voltage, let's just check the web data sheet itself. Yeah, so there are two sides. So on VCC, if you collect 1.8 and then VCC-B, you connect 3.3. You will get 3.3 on one side and 1.8 on the other side. And if you connect this to 5 volts, you will get 5 volts on one side and 3 volts. So it's just like voltage simple translation with 2 pins and enable. Yeah, these are all the characteristics. And then there are each data sheet will have some what to say, layout guidelines, how the ground plane should be laid out. But yeah, I didn't check too much on that. If it could be improved. So this is the internal. Uh, yeah, and then you just need to wire it up. And let's say you want to. Yep, there was example of wiring it one. So and then you check if everything is there. and then you just save, and then you click here, and then you'll come to the layout.
Is there
Uh,
any simulation of capacitance effects or things like that when we do the
of
layout?
There's a
uh,
calculator I saw.
I don't think there might be, but I don't know if that it affects, if there is simulation of the actual capacitance of these routes. Maybe there is. I don't know. Yeah, but for simple circuits, you don't need to worry about all these, unless you are doing like 4 layers and hundreds of components. You don't need to bother about all that. And
Why
then yeah,
doing 2 nanos with two of the voltage thingies?
because this on the right side. Uh,
I mean, the tumbler has just one chip that we're replacing, right?
yeah, but then you have to put it on the tumbler board itself, right? There needs to be a socket with 3.3 volts, which goes into the tumbler board, and then there needs to be a socket with 5 volts which goes into the tumbler board, and then you need another socket for with 3.3 volts.
No, that's not what I'm asking. Are there 2 nanos in this board or one? That's what I'm
No,
asking. It's just
no.
one.
So yeah, so the other one side is the board nano socket of the
Okay.
tumbler board. I didn't write tumbler, but basically on the right side, if you see board nano socket, that means that goes on the tumbler board, and then here is where you fix in the nano ESP32.
Okay. Yeah, I'll have to see photos to really get it, I think.
This is a 3D simulator or renderer. So this is where you'll. So after you solder here, you will solder the male pins headers here, and on the left side you will solder the female headers, and then on the left side you can like plug in the nano ESP32, and then after this, these male sockets can go into the tumbler port, which already has the female.
Okay.
Yeah.
Oh, yeah.
And is that a mounting hole underneath A2? Or how else are you going to mount this thing?
Yeah, it's a mounting hole because I wanted some support. So there are these mounting struts, metal struts, right? So I wanted a hole for that, but maybe it became too big. So I don't know because I couldn't find one at the time to measure it. So I just put a 2 millimeter M2 strut header, and
That could be about right.
Yeah, I'll just buy a M2 strut. And
How
then
does it? What do you got? Like, there's only one though.
because I don't need more than one, right? So
Why?
because if you see the tumbler, this side will be supported with the pin headers, right? And only and they only
I
this.
see.
Right.
So
That's what
only
I was
one.
asking. If you look here, if I'm understanding, let me actually show over here.
Yeah.
So this thing is where the board currently is. I assume you'll take this out and put this square board in, and the nano will actually be on the overhang part, right? It'll be kind of like
Yes.
jutted
Yeah.
out.
Yeah.
Okay, now I get it.
And then for that overhung part, I needed a support, so I just
yeah.
put in a hole. Yeah, like I just randomly put M2, but then I'll have to buy the M2 struts. I don't know if I have the M2 struts or not.
Okay, yeah, this will be kind of interesting once it goes on the board.
And yeah, and then the first thing you do is use the edge cut layers. Is it visible? I don't know how to make the font bigger here on the menu. So there is a layer called edge cut on which you draw the outline of the board itself. So I just measured 4.5 into 5 millimeters into 5 millimeters approximately, and then drew a square, and it will cut according to the edge cut layer. And then After you have done the schematic properly, you can go to tools and update PCB from schematic. So what would
Oh,
it will bring all the components you have on the schematic here on the board.
that was the very not intuitive part. That
Yeah,
I
because
couldn't.
because when you find a mistake here, and then you correct the schematic. Let's say, so what happened was, like, initially I designed a board and with a switching uh, like regulator which brings out the voltage to 5 volts, but that component was not available for manufacture, and it would take like 3 or 4 weeks for them to source it. So then I had to keep searching on, so I had to go through this cycle like 4 5 times, because sometimes the footprint would not be available, sometimes the JLPCB would not have the component, and sometimes some other problems. And then and sometimes the buck converter company would say that this is an obsolete component, don't use that. So like there are like two three places where you have to check like everything is working. And then finally I settled on this Diodes Incorporated, which was they had like enough supplies for manufacture. And then yeah, basically I got the footprint from SnapEDA and then placed it here. So you will get all these components and then you can move them around. Let's say, yeah, you can move them around here and you can place them wherever you like. So it all these blue lines you see, so when you just are beginning the board, you will get just the components and nothing else. So here, so it will be something like this, and all these components and nothing else would be there. And so you need to place all these components where you would like to, and then there is a good, so, and then finally you have to route it. So routing is the most tedious part. Yeah, but fortunately there is a plugin, so you can go to the tools and then external plugins, and then how do I install plugins? Plugin directory, not this one. Okay, it's here. That was also it's a confusing. It's not here if when you want to install plugins. So if you go to the main KiCad window and then here plugin manager, and then you can just search free routing, and then you can install this one. So what it will do, it will use some, oops, and then once you have placed the components, you can just search start the free routing tool. It will start routing. I don't know why it's crashing, but it's crashing now. So it will, once you,
Oh, your audio just dropped out.
We don't hear you. Anuraj, we don't hear you.
No audio.
Meetup. It's probably the most important part. Anurag, we don't hear you.
Whoa. Terminated that Java process, and that took down the whole audio system.
We should just start providing our own commentary.
Yeah.
Yeah, well, I can't keep up with the speed this is happening.
Now we are designing the 3-body problem headset, and the aliens can now hack into Anuraj's brain.
But is there any way of giving feedback other than chats?
There. I think maybe I got his attention.
What's this? No.
By the way, there was an AI lip reading model released a few months ago, no?
Oh, was there?
Yes?
Yeah.
I think there was one.
Oh, things like that.
But the thing that with Anuraj angle, I'm not sure it will work at all.
Yeah.
I don't know. Can you lip read from the side?
I'm gonna guess.
But
I'm gonna guess not.
perhaps. Yeah. If we are to believe the 2001 movie, it must be from the front. Huh? No,
Why
no,
would
it's
you
from
not?
the side. It's from
No,
the
yeah,
side. in the
Anuraj
movie,
wrote
actually.
what he's doing. He's leaving and coming back.
Yes. Last year, we Joshua showed us. Was it last year? Flux. Okay. And Anuraj mentioned about Flux at the beginning. I wonder why. He said, Anuraj said it was confusing. I don't know, from the preview of KiCad today, for me it looks very similar.
Yeah, I think that there are like maybe some big missing features or something,
okay.
and like a lot of like if he doesn't, especially around component selection, I bet it's pretty limited. Oh, there he is.
Yeah.
So what happened? I was wondering what gives why the views are changing, but then I didn't realize that I'm not audible.
We have 12 minutes of your video.
Yeah.
Without sound.
Okay.
Let's pull up the live stream and then you can narrate over it.
Yeah, but I can edit that later on.
You would have to remove Venkatesh trying to explain what you're showing.
Okay. Well, we'll see how the stream went, or I can explain the rest later on. Yeah, because I use a lot of tooling to route my audio, and then sometimes it gets messed up.
I think it was as soon as you killed that Java process for auto routing.
Okay.
It basically died at that point. I was like, oh no, he killed the wrong thing.
Okay.
So basically, when I stream with OBS, it requires a special audio tool to route the software so the audio quality is higher. And sometimes it's like stops working. I have not been able to figure out why it stops working sometimes. And then with StreamYard, I have to stop that process. And I don't know how KiCad is interacting with that audio, but yeah. But what did you miss?
The last 20 minutes.
Okay.
Yeah, so we missed, basically you were at routing.
Yeah.
And then you were like going through, I think, some like the whips and like stuff like that. We couldn't hear that. And then from there all the way into like the manufacturing thing. And
Okay.
I saw you create like a spreadsheet
Yeah.
in there.
Yeah. Okay, so basically, once you have routed, use the free router. We will not use it again, but once you have done the auto routing, it will not route everything correctly. So because like it's not as efficient, and sometimes you have to route manually, if and sometimes it will like not be able to route each of the pins. So what you can do is do the design rule checks here, and then
You're not sharing the screen anymore.
okay.
So did you install design rule checks for? I saw you had like PCBWay plugin or something in there.
No, the design rule checks is a KiCad tool itself. So
Okay, so
what
it's like
it will,
internal to that. But aren't there like manufacturer specific limitations as well? Like they have
yeah.
to be
So
a
I
certain
think,
distance apart.
yeah. So I think when you start a new board, you can set the rules in like, yeah, it's file board setup, and then I think there are like tolerance limits of the different things. There's one place called board preferences. Maybe it's this one. Yeah, and then here you check the, where is it? There is a place to, yeah, I'll have to search. So there is a board, basic board defaults which I use. So it will check, it will set the thickness of these routes, and the distance between them. So when you are routing these lines, what you need is like you need some tolerances between them. So that is also set. And generally what you do is like you fill all the empty spaces with ground planes or some voltage planes.
Mm-hmm.
So and then this is like a fill zone. So you can, what I did was like use a fill zone and then put the entire board dimensions and fill the entire board with ground plane on top and bottom. So it will automatically fill in the empty zones once you have like put the polygons inside. It will fill all the polygons which are empty. So you can basically, let's say, have this one, and I think there are some tolerance limits for that too. So this is like a fill zone. So you can have like multiple fill zones and you can fill in all the empty. I think JLPCB recommends at least 35% of the board should be filled with
Why is that?
some, I don't know the electrical rule designs, but I when I went for manufacture the first time, it said, okay, this board does not have like it's filled less than 35%. So fill up all the empty spaces with ground plane. So that is what I did.
Yeah.
There might be some electrical reasons for it, because in high speed circuits it matters. This is not a high speed circuit. I think like it's because of the like EMC radiations. So what ground plane does, it will absorb many of the uh, like electrical signals, and there are also tolerances about the angles between these. So because when high speed circuits, these high angles will cause some problems. So there are also tolerances for that, but that becomes really specialized knowledge. I don't have that much knowledge to do.
How are you? So you're grounding. You're not grounded to a ground plane. You actually have
So
traces
basically,
to
yeah. So
ground.
you just fill in the uh, so before you start the routing, you fill in the ground planes. So what the auto router will do is like make these vias. So
Mm-hmm.
vias are basically like holes, through holes that goes from one layer to the other side, and there is copper inside. So this is like a 5 volt via. So it will place some vias in the ground planes, and then it will automatically get connected. And sometimes what happens is when you have filled in the KiCad like fill zones, uh, some of the fill zones will become islands, because the outer router will not be able to like go through them, and it will go through them, and then it will cut off the fill zones. So I had to manually route these lines. So basically now this island and this island are connected, so I had to do a few of those. And what else problem? Yeah, these were the main problems I faced. So the outer router will not be the most efficient one, and then you have to manually do a few, and then you do the design rule checks. After you have done the design rule checks, it will tell you what are the problems.
What are courtyards?
Courtyards. So this is why, like, I saw Venkat smiling at this point. I thought, why is he smiling? I thought it's like he's smiling because of I ignored all these errors. But basically, I think there is. So, so when you are placing these components, it will have some footprint, and then there is some tolerance of this when these footprints and the silk screen are overlapping. I think it gives you some errors. But I ignored all these footprint related errors, because that doesn't actually affect uh, the electrical connections. So what I checked for was basically like the electrical connection DRCs. So once and it will say here in the unconnected items if there are some major errors, you will know. And then basically I ignored a lot of. You can just add these to the ignore courtyard overlap violations. Then it will ignore all of them. And then it will give you, if there are some major electrical violations, you need to run the DRC to check if there is after the auto routing, and then you have to manually route those lines. And after you are done this, you need to go to the plugin. So each of these manufacturers have their own plugins. So you can go to the plugin manager and then install these plugins. Where did it go? Yeah. So Isler is a German manufacturer, and then PCB Way has its own plugin, and Fabrication Toolkit is like for the GLPCB. You can install them, and then after that, you can just click here, and then it will. You can ask it to generate the manufacturing files. It will generate all these, yeah, all these files. So this Tumblr plugin zip file is the Gerber file, which you need to upload when you are starting the manufacturing process. So Gerber files is some old PCB layout file format, which is used for that you feed into the machine. I don't know the history of it. You can on Wikipedia, but you need these files. So each of the layers will have the Gerber files, and it will generate in and put it into a zip file. And then you need the BOM and the positions, these two Excel files, because it has to know where the components are and what components are there. And you might need to edit this BOM file, because right now I don't need these two Arduino Nanos. So I deleted these and then save. And then you need to do the same in the positions.
It looks like you could have. Sorry, I've also got KitKat open. You can select in the properties of your schematic. You can have it excluded from.
Yeah, you can have it
bill of
as do not
materials.
place.
Yeah.
You can have it do not place, but I think when you import it to PCBWay, there is an option of do not place in the GLPCB website itself. You can do it there also. So once you are here, So you can add the Gerber file. So this is the starting page where you are beginning to manufacture, asking it to manufacture, and then you add the Gerber file. It will process the Gerber file and make a 2D representation of it. So you can like have different you can also manufacture it as a flexible board, but I think that's a little more pricier than just FR4 manufacturing. So then you can choose the color you want. I chose lead free, and for the first board you manufacture you also get some discount. Then two-sided uh economic, I don't know, maybe this is some more precision. What's the difference? I don't know. Yeah. And then here you add the BOM file, add the position file, and process them. Yeah, here is you will have to select the actual component that you want to get placed. So either you can source it from somewhere else. I haven't tried that, but or you can ask it like, so this C2823 is the JLPCB part number. So each of the parts they have in inventory has its own part number. So you will have to search which component you want to place. I have forgotten what it was. Maybe. Okay, let's.
And so this
not
is
play.
because you hadn't looked it up before. What?
Yeah.
You hadn't validated all the components.
Yeah. So when I manufactured it, I knew it, but let's see. I remember it. There was some, but let's ignore this one, and then you can go to the next page, and it will ask you for the part selected. So here it will generate the actual PCB two layer, and then you can rotate the components if it's correct or not. So this one is not placed, but what sometimes happens is it's not in the correct orientation. So then you can change the orientation and then
Wait, so how do you know? How do you know about the orientation?
Where did it go?
And that's because it's coming off of the. It's like they're placing the parts.
I don't know why it didn't. Yeah, maybe it was because like the positions. Yeah, so when I exported from KiCad, I didn't have the orientation set in the schematic itself, I think, and that's why this couldn't. The Gerber file might not have the a related position, or maybe it's in one of the
There's
files.
a
I think the
CPL.
yeah
Yeah.
yeah I think it was in the Excel file that the position was not correct, and that's why one of the components was not correctly placed, and I had to correct it here.
But what told you that it wasn't
Uh,
placed correctly?
so it showed me. So each of these components, you see this dot here. Not zoom. So you see this arrow here,
Yeah.
the small arrow. So that is the first pin,
Okay.
and you see this dot here, U4 dot. So when it renders the actual, uh, let's see, just render and see. So when it will render, it will show a pink dot on the board itself, and then you can know it's facing the. You see this. So this
Oh, I see.
pink dot and white arrow should match.
Yep.
And for this component, it was not matching, and then I had to rotate it. So you can rotate the orientation here.
Oh, I see. Cool.
And this, yeah, for like SMT components, this is like really important, because after manufacturing, most people wouldn't think that there is a mistake in orientation on the manufacturing. and then it becomes really hard. Everybody is assuming, the hardware guys will assume that they have done it correctly, the software guys will assume they have done it correctly, and then nobody, like after the manufacturing, like nobody like thinks about like there could be a orientation mistake in the manufacturing itself. And because from the by looking at the board itself, like from the top you will see that you won't know what is underneath, right? Because the pin orientation. So it will be really difficult to know in which with the pins are just beneath the chips, and there is no way to know like if the chips have been placed in the correct orientation. So like yeah, that is like basically experience based uh, like knowledge, that you could sometimes you have to desolder the component, then see if the orientation is correct or not. Yeah, but like those mistakes are really rare, but they do happen.
Yeah.
And really hard to debug. And when like assume this is just a simple board, so you can just look and see. But if it's like hundreds and hundreds of components, like how would you know which components are? So I think like there are like several checks people do, like core placement reviews. If the hardware engineers also have these, I think there are like, I think more the paid ones have some tooling to check these. So I think Altium might have checks regarding those. Yeah. So this was
Fascinating.
crash course with
Yeah.
15
Super helpful.
10 minute 10 minutes of audio cut needed.
That's okay. I probably needed to see at least 2 or 3 times. Once with no audio, now with audio. Now I just sleep on it, and you can send me. We can do it again.
Yeah, but it's better to go through it by yourself, because like
Yeah.
I don't know, I might have missed some points, and then I don't know the entire process myself. I just winged it. Let's see if there are bugs or not.
Yeah. So I want to try to recreate the I don't know if I can show up on in front of me.
Oh yeah,
The one that I hand built here with
Yeah.
for the motor driver, and try to do one that'll, because that supports 2 motors, and I want to try to make one that will do 4 motors, and then plug into like a nano or something.
For people in the US, you could try this OSH Park, OSH, open source. I don't know what it's called. OSH Park. Yeah, so this is like, I think a US based manufacturer. You could try them.
What's it called? Off. Drop the link.
OSH Park. Yeah. Yeah.
Purple PCs.
This one.
Cool.
So here you can just drag and drop the entire Java files and then place it. I don't know if they have their own sourcing or not, but they might have some like tie-ups with DigiKey from which they source.
Wonder where they're based.
Yeah, that was it for today.
Thank you for the complete review. Huh?
Yes. Okay. See you
Cool.
next week.
Thank you.
See you next
Later.
week. Thanks again.
Bye.